Hey everybody, this is SortIQ software for the CS 7.2 case sorter. I wrote this to run on a Raspberry Pi, so this is fully housed on a Raspberry Pi that's connected to the 7.2 case sorter control board. No PC hooked up. This is all running on a Pi, so this is a web app that is broadcast from the Pi. I'm currently on my trainer PC, which is in my office. This setup's actually in my shop. So it's on the same Wi-Fi, or it's on the same network. I'm just connected Wi-Fi. Uh, the training is actually done on a PC, but the actual system runs directly on the Pi. So what we're doing is training a model. That model is actually training a smaller model, which gets loaded on the Pi, and everything runs directly from the Pi with no PC setup connected directly. But again, we're going to zip through this about as quick as I can, try to keep this short. But we do have our workflow over here, and we have our setup pages over here. So we'll start with workflow, but collect. So this is single capture mode. Pretty much like the existing software. These are all the classes that I have created over the last couple of months. This is all the brass that I've run through it and separated everything as much as I possibly could, playing around with it. But it's single feed. So as you stick brass in the machine, start running it through, it's going to actually capture it. Of course, I have everything trained already, but I do have prediction turned on. It's going to tell me that it thinks it's a PMC case. It's going to highlight PMC. If I want to save this case and feed to the next one, I just click the button. It's going to save it, feed it. If I don't want to save it, feed it, I can just clip skip and feed. It's going to skip that case, feed me the next one. Of course, I have a retake button. If I don't like this image for whatever's looks blurry, anything like that, I can click retake. It'll retake it. We do get our highest number of classes are automatically pushed up to the top. So even though I have FC here, I also have FC here. So if FC pops up over here, what it's going to do is, let's see if I can do Winchester. Yep. So Winchester right here, and there it is, going to highlight it up there. So we can just click that. You do have a filter. So if you wanted to type in Win, it's going to give you all the different Winchesters you can do. If you want to type in a new one, if you want to create a new case, you can just create new case, hit enter, click the button. It's going to add a new class. You can save that case to it. What you do, if you save and feed, it's going to save that case and it's going to pop up down here. We have recent saves, so it's going to show you the last several cases that you saved. If you made a mistake, you can come in here and actually change it, move it to a different class, or if you don't want it, you can just delete it and it's going to get rid of it. That is single capture mode. So if we go to batch capture, this is probably the easiest way to do a whole bunch of brass at one time. You can literally load a mixed set of brass into your feeder, hit the button, start capture here, and it's going to run through. It's going to take a photo of every single case and keep running until you're basically out of brass in the machine, and then it's going to group everything into categories, into separate cards. So everything that's alike is going to get put on the same card all the way down the row. This is, of course, I have everything trained already, but it's going to do trained or untrained cases. So if it sees something that it doesn't know what it is, if it actually sees another one of those, it's going to kind of recognize that, hey, this is very similar to this one. It's going to put it on the same card. But you can actually go through and group everything together, or look at all your grouped cases. And then if you decide that you want to save those cases, you can come in here and literally just click file all. It's going to file all three of those cases at the same time. If one of these cases was wrong for whatever reason and you can't click file all, if you just click the case here, it's going to tell you you can move it to a different location, or delete it if you want. We also have unknown. We can set it aside and we can identify it later. It puts it in a different place, but I'll cover that later. These are all the cases that it ran through. It was a small run. I just said 27 cases, went through pretty quick. But basically groups it all together. It's the fastest way to load a bunch of brass on your machine, and get it all put into your data set. We also have camera set up here. Of course, we're using this stock camera. We have resolutions. We have presets, so you can actually save a preset. So once you find something that you like here, you can go up here and save it. So I have mine called Tune. This is how I'm capturing all my brass. There's not a lot of adjustments on the actual camera itself, but this is where you find the LED ring that's built into the system. So if you want to adjust it, you can crank up the brightness if you don't like where it's at. You want to change something. I definitely recommend finding a setting that you like and leave it there, and you don't want to change it. You want all your brass to look as similar as possible uh, for everything. We do have a primer mask radius. So right here is your primer mask radius. This is actually what the model's going to see. So this is your crop. So this is with the primer mask and the outer ring cropped out. So this is just the donut that we're looking at. It's going to automatically configure the outer rim. You can come over here and adjust that if you need to. I actually have mine turned down just a tiny bit to cut off some of the edge. And then, of course, primer mask you can adjust, and it will actually adjust your primer mask. Once you get that set up, you just kind of leave it alone. I do have a sharpness indicator though, so you can adjust the focus on your camera. You want the highest sharpness you can possibly get. So when I got mine, I mean, it was pretty good, but I think it was just done by eyeball. So it looked really good. Once I actually put the sharpness indicator in there, I was actually able to go in and fine tune the actual sharpness, get it way more in focus than it was originally. The sharpest image you can get creates more detail for the model. So you definitely want to adjust your camera to get your sharpness up as high as you can possibly get it. And of course, you can also feed cases through. Different cases are going to show different sharpnesses. So depending on the reflection, how shiny it is, they're always going to be a little bit different, but you want to get the highest levels that you can. Here's our train tab. So this is where all of our classes are listed with the basically number of cases, kind of tells you where you're at with your data set. So currently I have 7 classes that have over 500. I have 5 that are over 300. I got 50 that are 10 plus, and then I have 35 that are actually under 10. Now I can't train anything under 10, so we're not actually training those cases when we have less than 10. Let's sort by count here. So it tells you there's the highest ones all the way down. So everything 10 plus will actually get trained when we do a training run. Everything that's under 10 but above 3 will actually sort. So everything from here to here will actually sort, and it will sort properly. You only need at least 3 cases to start sorting. That's why it says gallery only, because it is sortable at that point, but we're not actually training it on the trainer. Training's a whole probably video in its own right, so I'm just going to skip that for now. But anything under 3 is just kind of a placeholder. So right now, I only have 2 of these, what I'm calling a Blazer Dash. It's just a placeholder, so I'm waiting for more brass. Anything in red for sure is what you want to try to collect. So any of these cases that come through here. So the next time I get another nozzler, it's going to pop it up to 3, and then it's going to start sorting it. But until then, it's just kind of a placeholder. It says, hey, I'm just waiting for more brass. Again, anything from 3 to 9, it's actually going to sort, but you still want to get more brass into it because you want to get it into the training mode. And anything 10 and up will actually train. It will actually sort pretty much all of these fine, but the more that you can feed it, the better it's going to get. Of course, we have our training models, and we have our models over here. So this is my trainer PC. So if I click this, it's going to pop this little dialog up. It's going to say, hey, I did find a trainer on this PC. And so then I can sync my data set. I can hit train a new model. Once it goes through and it trains the new model, it's going to give you a report on the actual model. The model does run itself a test scan of your data set and gives you some details, which is what's right here. So basically, it scanned 1,015 random cases throughout my entire data set, and it confidently and correctly process those at 99.9%. So that's how you get that 99.9% number. It basically took 1,000 of my 10,000 cases randomly and said, hey, what is this? And it came back and it said, yep, that's the right one. And that's how you get that number. So, but it gives you all your details, gives you all the classes that you actually trained it on. That's your current model right here. If you decide to go in and start playing around with something and you create a model that's worse, you can actually come in here and click restore, and you can restore a previous model that was working better. You can also copy your entire data set to a USB thumbstick. So you stick a thumbstick in the or thumb drive in the Pi, click this button, it'll copy your whole data set over to that thumb drive. Then you can bring it to your trainer and actually load it. Same thing with the train models. When you click sync data set, it's going to pull all those images over to your computer. So the first time you do it, if you have 10,000 images, it's going to take a little while. I mean, it's all over network. Um, it's pretty quick, but 10,000 images does take probably 15, 20 minutes. If you copy it all to a thumb drive, you can literally just bring it in here, plug your thumb drive into your trainer, put it in the right folder. It'll tell you where to put it. Uh, and then you're good to go. You can just start. You're still going to have to sync the data set. It's going to verify that the images you got are correct. It basically compares everything and it says, yep, everything's right. And then it allow you to train it at that point. Um, if you have, like what I have here is 9,700 images. So if I had another 100 images and I click train models and I sync my data set, it's only going to pull the new 100 photos over. It's not going to pull the entire data set back. Actually, the same with copying your data set to the stick. You plug the stick back in and hit copy over. It's only going to copy the new 100 images. It's not going to copy what it already has. That is your train page. So we go to dataset. This is where we have our models. So if my current model is my 9mm caliber, my 9mm V2 is what I named the model. That's actually also up here in the header. So it tells you, hey, which one are you using? Um, that's this right here. So I have a few different models. So if you wanted to switch models, you just go down here and switch. So now I have what I called an FC specialist model when I was playing around with FCs, trying to split all the different case stamps out. Uh, I actually have those split out now in here. But if you want to create a new model, just click the button, give it a caliber or cartridge size, whatever you want, whatever you're doing up here, give it a model name. You can actually copy all of your images from an existing data set, so you don't have to start from zero. So if you're creating a new 9mm model and you want to test around and play with stuff, you can actually copy all of your existing images over. You can also copy the model. So if you take this and it says, we're going to take 9mm V2's trainer or its model that is currently loading on the Pi, and we're just going to copy it over to this new model. So you don't actually have to go through and do a rebuild training. Um, you don't have to copy the images. You can literally just copy the model, and then you could load new images into it, rebuild your gallery, and you're good to go. And you don't actually have to do a training to get going on that. That's how you create a new model right there. Of course, you have your merge your data set. So if you just literally wanted to merge your data set without creating a new model, you could just pull all your files over. It's always going to copy everything and it's going to compare everything. So right now, if I took this entire data set, copied it into my FC specialist, it's not going to copy the FCs that it already has. Of course, here's your backup and exports. If you want to create a new class right here, of course, you can also sort by count. It's just going to do the same thing as it did on the other page. It's going to tell you, of course, all the red ones. You definitely want to add more. If you want to see what images are in your data set or in your class, you can come down here. So Blazor has 553 images. So you can scroll through each page, look at all the different images that you have. If you want to look at them individually, you can click it. It's going to show you the raw stamp that it took or the raw image that it took, and it's going to show you the crop. And basically, this is what the model sees. So if this isn't right, you can actually move it, switch it to a different place, or you don't like it, it looks blurry, you want to delete it, you can hit delete. It will tell you the sharpness though up here. So, and you can just sit here and go through every single one. So if you want to pull out head stamps, uh, for if these had dots all over them and they were all mixed in with ones that didn't have dots, you can sit here and go through and move them individually. So, or you can just hit select multiple, and it'll allow you to select all these different ones. And then you can come over here and just move all 8 of those to a new class. Up here is your what we're calling the gallery or the exemplars. So this is what the model's actually viewing when it's sorting brass. So all of these blazers, these are all blazers. This is all the same stamp. This is just 20 different views of that stamp. So some of them are very worn, look like this for whatever reason. Some of them are dinged, damaged, scratched, scraped. Some of them are nice and clear. Some of them are dark. But this is literally the same head stamp, and it's just 20 different views. The model wants a variety of views of the same thing in order to be able to tell you what it is. So the more variants you can get on the same head stamp, the better the model will actually be able to pull it out. Uh, but this is automatically decided when you uh, when you have all your images in there. This gallery is automatically decided. There's a basically a code inside the system that says go through and find the 20 most unique stamps that you can out of your entire data set. And this does scale. So I don't have, for example, Win plus P only has 4. And so it just takes 2. So it will scale based on how many images you have. So the more images you have, Norma, there's the same thing. So there's a whole bunch of different looking Normas. They're all over the place. Uh, there's 113 Normas down here, but it's going to pick out the most unique looking ones and group them all together so that if it ever sees one of these comes through, it goes, hey, that's a Norma, and it spits it out. I'll cover training and data's or class setups later, but in all reality, these two you would want to pull out and put them in their own class. The more you can separate classes, actually, the sharper it makes your model, better accuracy that you get. But I don't have enough of them right now. Blazor had plenty, FCs. We have close dots, or what I'm calling close dots, because it's got 2 dots closer to the FC. And then I also have FC diamonds, which is this. I have FC diamonds, which is diamonds on either side of it. So I separated them all out so it knows those over the dots. So families is everything that is in whatever family you decide to make. So I made a family called FC, and I put all of my variant FC head stamps into that family. So currently there's 7 different ones. Same thing with Blazor. All of these. So for some reason I split these all out. So different looking head stamps, and I put them all into a family so that they are all sorted into the same bin. This is literally for sorting only. That's all this does. It is going to sort every one of these into the same bin or into the same Blazor family, which is going to be assigned to a bin. It just an easy way to put everything together without going through and picking all the classes. We'll cover that a little bit on the sort page in just a second, but this is where you would create a family. So you just click family. I just want to create a family. As you type in the family name, you can actually, hey, suggest the members, and it's going to highlight them for you. So you don't have to go through and pick all the ones. You can actually just say, give me something and do that. Now, I've already created the Blazor family, so we don't need to do that. Dataset maintenance is basically everything to do with your data set. This is your whole data set. So these are all your classes, and these are all the images inside your classes. So down here in data set maintenance, we have a whole bunch of options for certain things. So scanning for mislabels basically is going to scan either your entire data set, or if you just want to scan Blazor diamonds, for example, you can just say, hey, just scan Blazor diamonds. We're going to click this. It's already done. It scanned the whole thing, and it says, hey, every image in there says that it's a Blazor diamond. Uh, if you want to scan the entire data set, just leave it blank. You just hit scan. Still just takes a couple seconds. It's going to go through, and boom, we're done. And so it scanned the whole thing, and it said every image that I have currently is reading as what it should be. So I don't have anything mislabeled. If I were to throw a Hornady in here and then hit scan, it's going to go through and it's going to find that Hornady, and it's going to pop up right here, and it's going to say, hey, this FC case, because now our FC Diamonds case is reading as a Hornady. It's going to flag it over here. It's going to give you a button to view it, so you can actually open it up and see it and say, oh, yep, that is a Hornady, and you can move it back to the Hornady, or move it into the Hornady thing. So this is just an easy way to go through, scan your whole thing to make sure you didn't actually put something in the wrong place. You can also scan for duplicates. Duplicates are basically the same looking head stamp all the way across the board. So if you have, you know, 10 head stamps that look like these two right here, for example, they look very, very similar. It might see these as a duplicate. It might be the same case. I might have just pictured it twice. And so it's going to see that, it's going to compare them, and it's going to say, hey, these two look identical. Let's just keep the one that has the sharpest image to it. So that little sharpness indicator that we had on the camera, it's going to find the one that's sharper, and it's going to say, keep this one. Let's discard the rest. It's kind of a good way to thin out some of your data, some of your classes that are fully loaded. Again, the model wants different variations. It really doesn't learn much from 50 cases that look identical. It wants difference in case stamps for the same class. It wants as much variation as possible. It's kind of a twofold thing. Again, it's too much to cover in this little video, but you still want a lot of views of the same case, but you don't necessarily want the same views of the same case. So that's how you go through and scan for duplicates. Rebuild crops literally just takes the raw image that you see and it just rebuilds your crops. So if you need to rebuild crops for some reason, you can click rebuild crops. Rebuild the gallery will go through and actually repick all of these images. So if you go in here and let's say you're going ham one night and you just throwing cases all over the place and you're not really paying attention to what you're doing and you get a whole bunch of mislabeled cases, you can come in here and fix all your mislabels. Or if you go in and scan, you find a whole bunch of stuff that's in the wrong place, you can go through and move all of those around. And then once you're done, you want to rebuild your gallery, and that will automatically fix your gallery images and get everything in the right place and get everything to where the model, it's telling the model, hey, these are correct. Um, so rebuild gallery is definitely something to do fairly often if you're moving stuff around quite a bit, or if you're creating new um, categories, if you're splitting classes, like new rep. I went in and split the blocky new reps from the ones that are thin. Once you get done with that, you want to rebuild your gallery. So then it go ahead and tell it, hey, these look like new rep thin and these look like new rep block. So that is your dataset page. So now we'll go to our test screens. So here's our test an image. You can actually take what's currently in the camera feed, or you can also just pick a file. If you want to click here, you can pick a file, pick any raw stamp or a crop stamp, throw it in here, and then you can classify it. We're going to classify from the camera because we already have one loaded. So I can actually see this one right here. It's an Aquila. But if I hit classify, what's going to do, it's going to pop up and it's going to say, hey, this is an Aguila case. So this is what the model saw. So this is actually the crop that it pulled. If I wanted to save this head stamp to my data set, I could click save and save it. It gives you all our checks right here. So we have our sharpness level. So I have a floor for my sharpness of 45. So anything under a 45, and again, my sharpness level is based off of that little sharpness indicator that was on my camera. So sharpness level has to be above 45. The reason it says 81 here is because I'm actually rotating that view 4 times. So I'm taking this picture during the sort run, and it actually rotates it 4 different times, in different positions all the way around. And it's saying, hey, when this thing's rotated 4 times, does it still look like an Aguila all the way around? That does actually help quite a bit with the sorting process, because if it sees a case that it's not quite sure of, there's a lot of cases that look very, very similar, but by rotating it 4 times, it gives it a different view. So during the sort run, we're rotating it 4 times. And of course, this one it says 4 views agree that it was an Aguila. And then the average sharpness of all 4 views is 81%. So even though I can kind of see that it's over 100 here, it's actually averaging at 81.4 for 4 different views. The match has to be above, greater than or equal to its threshold, which I have a threshold set at 85%, but it does auto calculate thresholds based off of the class and how well it knows the class. So this class, it knows it pretty well. And so I got a 95.6%, rate or percentage that this is an Agila. It also spits out the next closest thing to it. So it said, it kind of looks like this gecko case, but I have a 24% gap between those two. If it's less than 3%, it's going to kick it out. So if I had an FC case and let's say an FC Diamonds case, and they looked very, very, very similar, as long as that gap's over 3%, it's going to push it into the right bin, or the bin that it thinks it is, which tends to be the right bin. But that is the test page. The reason it says unmatched up here is because I don't actually have a current bin configured for that head stamp. So it's going to send it to bin 3, which is basically holding my classified no bin sorts. So it's the only reason it says unmatched up here. If there was a bin assignment, it would be green. It would say, I'm going to send this to bin 1. And your bin assignments are on your sort page, which is right here. So this is basically where you go to do all your sorting from. I did a previous sort run, so I ran 120 cases. It took 2 minutes and 7 seconds to run those 120 cases. It was about 1 second per case, and I had a 96% average confidence for that entire sort run. So of all the cases that it viewed, those 120 cases, 96% average correctness across the whole run. It gives you basically a number, so it's going to give you the date and then a unique identifier for that actual sort run, because we can actually view past sorts up to 5 different sorts of your 5 recent sorts. You can go back through and view all those. Of course, there's a green button if you want to start another sort. You just click that, and then this is basically telling you that we ran out of brass after 120 cases. So the feeder was empty after 120 cases. So it tells you that. And then I'm actually sorting the last 3 cases automatically. I know the original software, you actually have to take those back out and resort them, but I'm actually running them through. So they actually do run all the way through until the wheel's completely empty. Of course, we have our run options here. You can click this. It tells you right now that my machine's connected. Here's my acceptance slider. So 85% is my base floor, but it does shift each class. It actually tunes this to each class depending on how well it knows the class. That's why over here we were actually at 89% floor on Agila, even though my bar is set to 85%. There's a bunch of calculations that I'm not going to get into on that. Sharpness floor, again, this is where your blurry image comes in. So I want at least a 45 sharpness. You can come in and adjust that here. You can clear your slots, which will clear all this out. You can reset all your counters, which will reset all that. And then here's my bin assignments. So I currently have 8 bins. I have these 6 assigned with classes. And then I have these 2 here. I have unmatched and overflow, which I'll get into in just a second. But let's go to bin 1. So bin 1 actually has my Blazer family. If you hover over it, it's going to tell you all the cases that are in your Blazer family. So this was the family setup that I did on the dataset page. If you want to add another case to it, so if I want to send AAC and Blazer, it'll send AAC and Blazer to that bin. If you want to, let's say you want to sort out Blazer dots from your Blazer family, you can also do that as well. Even though Blazer dots is still in my family up here, by pulling this out and putting it in a separate bin, it'll override the family setting and it'll actually send all the Blazer dots to this bin by itself. It's always going to override your family setting, but it's an easy way to keep you from going back in and saying, you know what, I don't want to send this one to here. I just want to send the Blazer dots over here. And you can send all the rest of the Blazers up here. So it will always override the family setting if you specifically go in and tell it, I want this one in this bin. Of course, FCs, Here's all my FCs family, but I didn't have any FCs on this one. I only had the ones with the numbers here are what actually got sorted during my run. So I had 72 Hornadies went to this bin. I had 11 Winchesters. I had 12 Blazers. Uh, you have a bin size, so you can go in here and set the size of your bin. So this is how many cases your bin will actually hold. As you start running sort runs, it will start filling this bar up. And if you get close to the end, it's going to turn red. It's going to let you know, hey, you need to go empty that bin out. If you want to view the cases that went to this bin, so I had 12 Blazers that went to this bin. I had 10 regular Blazers. I had one Blazer Diamond and I had one Blazer Dots. And if you want to view those, you just click this button and it's going to drop down and show you what actually went to that bin. So we got bin 0. There was 12 classifier. Tells you it holds its Blazer family. Here's my 10 regular Blazers. So this is just what I'm calling a Blazer case. And then I had one Blazer Diamond, so there's a little tiny diamond right here in between the 9mm and the Luger, and it knows that that's a Blazer Diamond, but it was still in the same family, so it sent it to the same bin. And then this one has the little dots on it, so I'm calling it Blazer Dots. So all of these went to the same bin, but it still separated them out because it knows which one is which. You can also do the same thing. So we had 11 Winchesters go to this case, but they were all the same Winchesters. But again, 96 is my low, 95, 96, 97. Pretty confident. Uh, we also have an unmatched bin and an overflow bin. So unmatched is a default CS 7.2 setup. So anything that is not recognized, not classified, is going to go to unmatched. And also in the stock 7.2, anything that doesn't have a bin assignment will also go to unmatched. But I wanted to be able to split those two. So anything that literally can't get classified goes to this bin. This is the only bin that will hold anything that can't get classified. This bin holds my overflow. So anything that was classified but doesn't have a bin assignment goes to my overflow. So if we click this, we can see that all of these monarchs, it knew exactly what these were, but there was just no bin assignment for it. So it just sent it to that bin. Same thing with these Aguilas, all of these cases. It knew what these were. It just didn't have a bin assignment for them. So it puts them in my overflow bin. Actual unmatched or rejects, which I actually didn't have any rejects on this run, but we can go look at an old one. So here's a reject. We can load those rejects and it's going to tell you why it rejected it. So we had this TRN case that got rejected and it was rejected because it was too blurry. So this was, for some reason, this was below my threshold for sharpness. Could have been any number of reasons. I run the machine pretty fast, so it could have been vibrating, could have been, movement, could have been anything. For whatever reason, it didn't like that. Could have been the case itself, just tarnished, something like that. And it was too blurry to actually say, hey, this is a TRN case. So it just doesn't know what it is. So it kicks it, throws it into the unreviewed or the unmatched bin. If you want to view the entire report, we can go through and view the entire report. And these are all the cases that got sorted, which bins they got sorted to. And you know what, if we want to file something, we get this little green indicator that says, hey, we filed that. You can go through and actually run a sort run. And then if you find cases that you don't know what they are, or the machine doesn't know what they are, it's going to show it in here. Or you can actually go in and save it. So if I want to save this case to my data set, instead of actually doing the collection thing where the batch capture or the single capture, I can actually do a sorting run. And then I can come in here and say, you know what, I want to save this. And so I'm going to file it. So right now I've just filed it to my RP class. And so the next time I do a training run, that case will show up. So you can always save data no matter what you're doing. All right, so now we'll go over to our machine settings. So that's these three over here. Docs is pretty much just a brief rundown of everything to do with the machine, different settings you can do, different things, how to make your data set, what things mean. That's all over here in docs. So kind of tells you what it is, what's going on. It's just kind of a quick guide for certain things on the machine and how it works. The machine tab is actually your actual case sorter machine itself. So currently we're connected, so that's why we have the green bar. It tells us what we're connected to, which is the CS 7.2 board, and it also tells you the actual Pi setup if you really want to know that. Of course, here's our slot settings. So we have our test feed button. So if we want to test feed the machine, we can click this and it's going to feed. It's going to run a case through. We have slot assignments or bin assignments. So if you want to run the sorter arm to bin 3, you can actually sort it to slot 3. We can actually enable or disable slots. So you also have number of slots on the machine. If you want more than that standard 8 slots, you can come in here and increase this or decrease it. You can also turn on and off individual slots. So I wanted the ability to be able to literally just turn off slots. If I only wanted to have, 0, 1, 5, 6, and 7, I can turn those off. I hit save and it basically erases those from the machine. From the sorting runs, everything, they just disappear. It's like you don't even have those slots that exist, but slot 7 will still say at slot 7. So if you sort to slot 7, it's going to sort to slot 7. So you can turn off individual slots if you want. Slot calibration is actual positioning of the arm. So I'm running a custom firmware, which is right here. So if you're running stock 7.2 firmware on your actual 7.2 board, this is what gets shipped with it. You can actually come in here and click that. You lose all the functionality that I've created. But with the actual Fort firmware that I've run, you actually have positionings of the slot arm. So I'm running a custom manifold setup where I'm actually spitting the brass through a tube into a manifold that's running into tubes. And it's kind of a crazy setup, but I needed precision, a little more precision than I was getting with the actual stock firmware. So I created this other firmware that will actually give you specific slot assignments. So I can go in and move the arm to an exact position, less than a millimeter travel, depending on how far I needed to go. So 16 steps, or 16 is a full step on a stepper motor. I'm not going to get into the nerdy stepper motor stuff, but you can go through here and adjust positions of the arm to get exactly where you want it. And that's through slot calibration. And it will save those automatically. I'm also tweaking quite a bit of the way the steppers work with some accelerations, decelerations, things like that. Homing, we're actually homing the sorter arm kind of like a 3D printer, so it'll actually hit the stop, back off, and go back in, so that we get a exact, precise position every single time. Um, Again, with the acceleration and decelerations that I'm doing, I was actually able to speed it up a little bit, make it a little bit smoother. But these are all the custom settings that I've done, so you can go in and tweak those as you want. Or you can, again, just run the stock firmware. You get all the stock settings if you're not running the custom firmware. We also have our serial console log here, our serial window, so you can actually do all the things that you could if you were connected serial. So if we click version, it's going to tell us what version of the firmware we're running. So you can see I'm running the 7.2, but it's the -SS2, which is my custom firmware. You can home the sorter. It's basically going to do that. You can pop this out. So if you wanted to leave it up and running while you're doing something else, you can come in here and move this around so you can watch it actually run and see what it's doing. It's kind of good for troubleshooting. But that is your console log. So this is your page for your machine. Fleet page is basically where we're going through and let me rescan. I lost my Pi 4. There we go. So if you have multiple sorters set up with Raspberry Pis on them running this software, it's actually going to pop up here on the fleet page. So currently I have my Pi 4 just sitting here. It's not even connected to a machine, but I'm just using it for a test for my fleet. So that's why we don't have a camera or board connected. That's why there's a red. This one's actually hooked up to the machine. And so that's why we do see a camera and a board, and they're green. It also tells you the firmware that it's running. So these need to match across the board. This is my trainer. So my trainer PC, the one that's actually housing the trainer that's training all of the Pis. And so it also runs on the fleet management. So currently we're connected to this one right here, and it's called 9mm Masters. That's what it's named up here. So we are 9mm Master. If you want to change the name, you just click it. We can actually go through and change the name. If we want to switch to a different machine, we can literally just click it. It's going to open up a new one. So now we're actually on the Pi 4. I don't have a machine connected, so there's nothing hooked to it right here. But that's under our fleet page. And now if we pop up over here, we can see that we're on our Pi 4. So it tells you we're on this machine, and now we're not connected to this machine. Now, what I can do is go to sort. I can start a sorting run on this machine. Of course, again, everything's defaulted. There's nothing mapped. I have no data. I have nothing on here. But we can actually start a sort run on that machine, and then we can switch back over here to our other machine, and we can start a sort on that machine, and that's all going to be controlled from our fleet page. Uh, the trainer again is just it still runs the software just like everything else, but this is actually the trainer, so it tells you up at the top that we're on the trainer. But that is the fleet page, and so you can have as many units as you want. If you had 20 sorters running with Pis on them, they would all show up here, and you can click back and forth between them and do all sorts of sorting runs on different machines. Since we're on this machine, that's my 9mm master machine, which is actually connected right now, we are getting a green indicator up here that we have a camera hooked up, we're on network, and we have our little gear icon up here, which tells us which build we're running on this machine. And then we can restart the app, which is basically our web page, or we can actually reboot the Pi if we're having some kind of issue. We need to reboot the Pi for whatever reason. We can do it straight from here. Pretty much that's it for now. Like I said, I will run through every tab in a little more detail on a different video, but it gives you kind of a quick rundown of everything, how it works, what it can do. And if you have any questions, put them below.